This is Paul, the SDR guy, and today we're going to update you on the homebrew HF transceiver project that I first mentioned in the episode 7 video. We're going to be using GNU radio, the red pitaya, and I should also note that the TRX Duo, which is a red pitaya clone, will also work. We're also going to be using the AirSpy HF Plus Discovery SDR. I'm collaborating very closely with a very good friend of mine who wants to remain anonymous. As many of you know, I have tremors and I am not able to solder. So I have a great friend that's very skilled in this and many other areas that has gladly assisted me. Well, I've mentioned a little bit about the parts. I've mentioned episode 7. Let me just give you a quick review. What we're building here is a homebrew or homemade HF transceiver. And we will be using GNU radio to perform the modulations. We will be using a red pitaya. The GNU radio software will output to the red pitaya. The red pitaya is an excellent HF exciter. It has a 14-bit digital to analog converter on it. So the output of that will go through a power amp, and then we have a band selectable HF filter bank that will filter things before we send the signal on through to the antenna. And here's a picture of both the SDRs and the dimensions for this particular project. This all goes in a 12-inch by 12-inch box. It's about 3 inches tall. And in this picture, if you look at the green LEDs, you'll see it starts at the bottom, 160 meters, 80 meters, 40 meters, so on and so forth. The little red LED that you see here is the coax relay switch, and it's basically the push to talk will energize this. On the right is a simple power switch. On the back of the box, we have a single antenna, and we have the receive SDR that will be connected here, the transmit SDR here. In normal, when this whole thing is powered up, the antenna will be connected through a coax relay to the receive SDR. When the system transmits, then the coax relay changes and the transmit SDR will be connected to the antenna. Here's the simple PC mic that I'm using, and if you look here, there's a little button there that you can push to talk and push again when you're finished talking. Let's look inside the box. Up here in the right-hand corner is the FT232 age board, and this allows me to write a Python program and send commands out to the board to turn on or off GPIO pins. This stands for General Purpose I/O. Over here in the middle is a wideband 2-watt power amp. If we look at this picture, where I'm pointed to now, this is the coax relay. Over here on the right is a repurposed Kenwood HF radio filter bank. And my friend was able to buy several of these boards, and as I recall, this thing cost $11. So Rather than this going to the landfill, we were able to repurpose this and at a very, very reasonable price. Here's a better view of this filter bank. In this picture, if you look up here where I'm pointing, this board has a number of opto couplers. Well, why do we need that? Well, the filter bank that you see here requires 12 volts, and our FT232H board just outputs a little over 1 volt. So this in essence allows us to control the 12 volt relays with the low voltage GPIO pin output. And here is a schematic of the project. Here you see the lines coming in from the opto coupler, and of course that's energized from pins C1, so on and so forth, from the FT232H. So whenever one of these energizes, then if you want to talk on 160 meters, then this particular filter will get energized. And the same is true for the other filter banks here. I want you to notice down here we have a push to talk, and what it is doing, it's controlling this coax relay. So as I said earlier, this system, when it powers up, the one antenna is connected to our receive SDR. However, once we key this up to transmit, then we'll be having a transmitted signal coming from the red pitaya into this 2-watt broadband power amp. The output will go through the appropriate filter band, and then it will go out the antenna. So there you have it. This is an update on the project. I hope you've enjoyed it, and please stay tuned for future updates. And once again, this is Paul, the SDR guy. I hope that you have a wonderful day, and please like this video and subscribe to my channel. Have a great day.